Hello everyone. In today's video, we like in the last video, we have discussed the laws of elimination. In this video, we are going to discuss about the problems on elimination. So we have two laws from the laws of elimination. So one law, it is about the inverse square law. So there we got to know that the elimination on a surface is inversely proportional to the square of distance between the uh, source and the source and the surface. The elimination second law says that elimination on any point on the surface is directly proportional to the cosine of angle between the normal drawn at that point and the direction of luminous flux. So we'll discuss the problems on this elimination. And the first problem goes like this: the flux emitted by a lamp in all direction is 1000 lumens, and we have to calculate the MSCP. So the flux emitted they have given, it is 1000 lumens, and the lumens is actually the unit of flux, and we have to calculate MSCP. So MSCP stands for mean spherical candle power. So the mean spherical candle power we have to calculate. So what does it mean? So it is nothing but what? It is the total flux emitted in all direction, correct? So this is nothing but the mean spherical candle power. So the total flux emitted F is equals to 1000 lumens, and MSCP of lamp can be written as F by 4 pi. Okay, so this is the flux emitted in all direction. Okay, so therefore we can write it as F by 4 pi. This is the formula for the MSCP, that is mean spherical candle power is nothing but flux by 4 pi. 4 pi is nothing but what? It is overall the if I take the sphere, then throughout the sphere, that is throughout the sphere means what? It is 360 degree, correct? So to overall 360-degree, like or how the flux is radiated. So this will be taken as MSCP of lamp. MSCP of lamp is nothing but F by 4 pi. So flux is 1000 divided by 4 pi will gives 80. So next, the second problem will goes like this. A 250 lamp has a total flux of 3000 lumens and takes a current of zero point 0.8 ampere. We have to calculate lumens per watt and MSCP per watt. So wattage of lamp is nothing but what? Wattage is nothing but what? It is the unit of power. So power can be written as voltage into current. So here we know voltage, and if we know current, correct? So therefore if I substitute, then I'll get the wattage of lamp as 200 watt. So thus we have calculated the wattage of lamp. And now the total luminous flux emitted is nothing but 3000 lumens. So MSCP is nothing but F by 4 pi. So whereas F is nothing but 3000, so therefore MSCP is equals to 240. Now we need to calculate the lumens per watt. So the name itself suggests lumens is nothing but output of lumens, output of lamp in lumens, and wattage of lamp in watt. So this will gives us lumens per watt. So lumens is nothing but it is the output of lamp, and wattage is nothing but input to the lamp. So this is nothing but the lumens per watt. So that is output of lamp is nothing but MSCP. Sorry. So output of lamp in lumens means what? They have given the flux emitted is nothing but 3000 lumens, and wattage of lamp we have calculated, that is voltage into current, which is nothing but 200 watt. So therefore lumens per watt is nothing but 15 over here, and we need to calculate MSCP per watt. So this is nothing but MSCP of lamp divided by wattage of lamp in watts. So therefore this is nothing but 240 by 200, which is nothing but 1.2. Like this we are going to calculate. So next we'll move on to the another problem. So determine the MSCP of a lamp emitting 1000 lumens. A surface inclined at an angle of 60 degree to raise is kept 5 meters away from a 100 CP lamp. Find average intensity of illumination on the surface. So here we need to calculate the MSCP of lamp, and also we have to calculate average intensity. MSCP of lamp here is, it is 1000 lumens, and the surface is inclined at an angle 60 degree. So that is the distance between the source and the source and the surface is 5 meter. So therefore we have to calculate this. So MSCP of a lamp is nothing but what? It is nothing but flux by 4 pi, which is nothing but 1000 by 4 pi, which is nothing but 80. And average intensity of illumination on a surface inclined at an angle 60 degree to the rays and kept 5 meter away from a 100 cp lamp is nothing but what? So by the Lambert's cosine law, we can write we can write the illumination as I by d square into cos theta. So here theta is nothing but what? Here they have given that it is inclined at an angle 60 degree to the rays, but this is not the angle which is nothing but theta. So this is how do I calculate this angle theta? What is theta? Theta is nothing but it is the angle between the normal drawn to that point and the surface which is inclined, and the light rays. So that is the angle theta. So therefore this is 60 degrees nothing but what? It is only the angle between the light ray and the surface, but we have to calculate the angle between normal drawn to that point and the light ray. So which is nothing but 90 minus 60, which is nothing but 30. So I is nothing but 100 cp, 100 cp lamp, and the distance between them is 5 square, and cos 30 is nothing but 0.86. So this will gives you the answer 3.464 lux. So next, this is the important problem. A lamp of 500 watt having a MSCP of 1000 is suspended 2.7 meter above from the above working plane. Calculate illumination directly below the lamp at the working plane and illumination at a point 2.5 meter away on the horizontal plane from the vertical below the lamp. So here we have to calculate illumination at 2 points. One is directly below the lamp and 2.5 meter away from the lamp. So like here they have given the wattage they have given, and the MSCP they have given, and the height, that is 2.7 meter, that is also they have given, and we have to calculate the thing. So before calculating we have to write this diagram. So you can see here we have to write this diagram. So this is the lamp they are talking about, and the lamp is 2.7 meter away from the surface, and at the 2 points we need to calculate the illumination. One is directly below the lamp, that is at the point A we need to calculate, and we need to calculate the illumination at a point 2.5 meter away from this point. Okay, so we need to calculate, this is nothing but B. So therefore we have to calculate illumination at point A and point B. So let us list the data. And illumination directly below the lamp at working plane, which is nothing but EA is equals to again I by h square into cos theta again. Okay, so that is nothing but cos theta, but now the angle here is 90 degree. So therefore cos 90 minus 90, or cos theta is nothing but what? Here this is nothing but cos 0, that is the angle between the normal and the light ray. You can see here the light ray and the normal is parallel to each other. So therefore the angle between the normal drawn at this point and the light beam is 0 degree, because the normal is same as the light beam. So therefore cos 0 is nothing but what? It is nothing but 1. Hence I have not written that cos cube theta, because cos cube 0 is also nothing but 1. Hence we have not written that. Okay, so this is nothing but EA is nothing but I by h square. So I is nothing but 2000 and h is nothing but 2.7 whole square, which is nothing but 137.17 lux. So illumination unit is lux, or we can write as lumens per meter square. And we need to calculate the lamp efficiency. So lamp efficiency is nothing but what? It is nothing but luminous flux by power input. So luminous flux is nothing but 4 pi into MSCP. So whereas 4 pi MSCP is nothing but 1000, because the candle power, that is the luminous intensity, is same as MSCP. So therefore power input is 500, hence it is 25.13 lumens per watt. Next, third case is that illumination at a point 2.5 meter away on the horizontal plane from the vertically below the lamp, that is EB. EB is nothing but what? It is nothing but high by h square into cos cube theta. So here, first of all, we have to calculate cos theta first. So from the diagram, you can see here what is cos theta. Cos theta is nothing but adjacent by hypotenuse. So therefore, cos theta can be written as adjacent is nothing but 2.7. Hypotenuse is nothing but square root of square of sum of the adjacent and opposite side. Hence, it is nothing but square root of 2.5 square plus 2.7 square. Let us substitute over here. This is nothing but I is nothing but 1000, h is nothing but 2.7, and cos theta is nothing but what? It is nothing but 2.7. That is 2.7 cube divided by 2.5 square plus 2.7 square into 3 by 2, which is nothing but 54.2 lux. In this way, we can calculate this. And you can observe over here, if the surface is directly below or right below the lamp source, or it is perpendicular to the lamp source, then at this point illumination will be more. And now, if the surface is away from the point EA, or if it is inclined at an angle theta, then what happens? Illumination is reducing. Therefore, you can observe or conclude that EA will have more illumination, and compared to EB will have less illumination. So this is what the Lambert's cosine law also states. Next, we have next problem, that is two lamps are hung at a height of 9 meter from the floor level, and the distance between the lamp is 2 meter, and lamp 1 is of 500 cp. If illumination on floor vertical below this lamp is 20 lux, find the candle power of lamp 2. So this is something like tricky problem. Here they told that there are two lamps and they are hung at a distance of 9 meter, that is the mounting height is 9 meter, and the distance between the lamp is 2 meter, and lamp 1 is of 500 cp, and if the illumination on the floor directly below it is 20 lux, find the candle power of lamp 2. So let us list out the data. First of all, we have to write the diagram. So here this is the two lamps we are having, that is L1 and L2, and the distance between them is 2 meter, and they are 9 meter away from the floor. Okay, and we have to calculate, and they have given the illumination directly below the lamp. Okay, that is this point will have more illumination, right? So here there will be a that is the illumination they have given, and we have to calculate the candle power of lamp 2. So to calculate this, illumination at a point A on floor level vertically below the lamp L1. So you can see here, if I take the illumination on the point A, so this point A will receive the light from both lamp 1 and lamp 2. So therefore, the illumination at that point will be the sum of illumination due to lamp L1 plus illumination due to lamp L2. So here, this point they have given, they have already mentioned in the problem, that is illumination at a point A is 20 lux. And if I take the directly below the lamp L1, then it is not inclined. So therefore, it is only I by h square. I is 500, and h square is nothing but 9 square. And if I want to know what is the illumination due to lamp L2, which is inclined, so therefore I have to use the formula I by h square into cos cube theta. So I don't know. So this illumination, sorry, luminous intensity or candle power I have to calculate. So therefore it is written as CPX. And again, mounting height is 9 square, and cos cube theta. So the cos cube theta is nothing but what you can write over here. So this is opposite side, and this is hypotenuse, and this is adjacent side. So cos cube theta can be written as what? It is adjacent side. So the adjacent is nothing but what? It is nothing but 9 by square root of 2 square plus 9 square. I can write in this way, or I can simplify and write this. So therefore, how do I calculate CPX? Let us rearrange the terms, and therefore CPX is nothing but 1204 candle power. Like this we have to calculate. So next we have the light source, a small light source with intensity uniform in all direction, mounting at a height of 10 meter above the horizontal point, a horizontal surface. 2 points A and B both lie on the surface with point A directly beneath the source. How far is point B from the point A if illumination at point B is only one tenth of the great as at point A? So let us first write down the diagram. So this is the one lamp we are having, and point A is nothing but this, and the mounting height is 10 meter, and we have to calculate what is the distance between the point A and point B. So let us define this as x meter. Illumination at point A is nothing but what? It is nothing but I by h square only. So which is nothing but I by 10 square. I don't know the candle power. So this I have to calculate. So which is nothing but 100. And illumination at point B, it is nothing but I by h square into cos cube theta. So cos cube theta is nothing but what? It is nothing but adjacent by hypotenuse, which is nothing but 10 by square root of 10 square plus x square. So I don't know I have to retain as it is. And in the problem they have given that illumination at point B or illumination at point B is only one tenth great as at point A. So therefore I can write as EB is equals to 1 by 10 into EA. So let us write down the term. EB I know, let us substitute, and EA I know, let us substitute. So therefore, I want to calculate x, and here you can observe I and I will get cancels out. Okay, so therefore x I can calculate over here. So this is nothing but 3 by 2 root we are having. Now let us do the squaring on both sides. So upon do the squaring, or I can transfer this 3 by 2 root to this side, so therefore it will become 2 by 3, and x I can easily calculate, which is nothing but 19.1 meter. In this way we can calculate the we can easily calculate the term. So next we have the another problem. So a lamp having a uniform candle power of 200 in all direction is provided with a reflector which directs 60% of total light uniformly onto a circular area of 10-meter diameter. The lamp is hung 6 meter above the area. Calculate illumination at center, edge of the surface with and without reflector. Determine also average illumination over area without reflector. That means what? Here we have a lamp source or light source. So this lamp is covered by the reflector. So when I use the reflector, I can easily direct the light into the particular direction. So therefore, the reflector will direct only the 60% of total light which is emitting by the light source, and the 40% will be absorbed by the reflector. So let us list out the data. Candle power of lamp I is nothing but 200 CP, and you can see here. So this is the lamp we are having, and it is surrounded by the reflector. And at point A we will get maximum illumination, and we also have to calculate illumination at point B also. Okay, so to calculate this illumination at center of area without reflector. So first of all we are calculating without reflector. So which is nothing but I by h square. So 200 by 6 square is nothing but 5.56 lux. Next, illumination at the edge of surface without reflector, which is nothing but I by h square into cos cube theta. So to calculate cos theta, it is nothing but what? If I consider this triangle, it is nothing but adjacent by hypotenuse, which is nothing but 6 by square root of 6 square plus 5 meter square, which is nothing but 0.768. So therefore, which is nothing but 2.52 lux. Next, we have to calculate with reflector. So with reflector at edge and at the center will be same, since reflector directs light uniformly on the surface. So therefore, at the center there will be a no difference, that no difference, and we will get my same illumination as without reflector. So the total lumens given out, how do I calculate? Which is nothing but 4 pi Cp. For CP is nothing but 200, which is nothing but 800 pi lumens. So the total lumens reaching on the surface, which is nothing but 0.6 into 5. Why we have written like this? Because only the 60% of the light is reaching the surface, and the remaining 40% will be absorbed by the reflector. So you can see here, so this is the total lumens given out by the lamp, but the reaching the surface is only 0.60%. So this is been given in the problem, and only 60% is receiving 60% will be directing towards the surface, hence the 40% will be absorbed by the reflector. Hence, the total lumens reaching on the surface is nothing but zero point 0.6 into 5, which is nothing but zero point 0.6 into 805 lumens. So, what is the total surface area? It is actually the circular area. So, it is nothing but pi r square. Radius is, or the distance between point A and B is 5 square. Hence, it is 25 pi meter square. And average illumination is nothing but what? It is nothing but total flux divided by unit area. So which is nothing but flux by area, which is nothing but 19.2 lux. And solid angle subtended by area at lamp. So we have this from the relation, and that is the relation between solid angle and the plane angle, which is nothing but 2 pi into 1 minus cos alpha by 2, or we can write it as 2 pi into 1 minus cos theta. So here 2 pi and cos theta we know, let us substitute. So this is nothing but the 0.464 pi steradian. So this is the solid angle subtended by the area at the lamp. And the total flux reaching the surface is nothing but what? It is nothing but I into omega. So therefore, it is nothing but 92.85 lumens. And average illumination is nothing but what? It is nothing but total flux by area, which is nothing but 92.85 divided by 25 pi, which is nothing but 3.7 lux. Like this, we had to calculate. And we have the another problem. The two lamp posts are 16 meter apart and are fitted with a 100 cp lamp, each at a height of 6 meter above the ground. Calculate illumination on a ground under each lamp and midway between the lamp. So here we have two lamps and we have to calculate illumination directly below the two lamps and midway between them. So let us list out the data, and first of all we have to write this diagram. So here we have the two lamps L1 and L2, and we have to calculate illumination at directly below them, that is A and B, and we have to calculate illumination at point C. Okay, so you can see here illumination midway between the lamps EC, if I want to calculate, which is nothing but illumination due to lamp L1 and illumination due to lamp L2, because at this point C you can observe, the this surface is or this point is illuminated by both the lamps, but it is not in the case of A and B. At point A only L1 is illuminating, and point B only the flux is like we are getting the light from the lamp L2. But at the point C, we are getting the illumination from both the light sources. So therefore, we have to write in this way: EC is nothing but illumination due to lamp L1 plus illumination due to lamp L2. Again, I by h square into cos theta will be the cos cube theta will be the formula. I is nothing but 100 cp, and h is mounting height is 6 square, and cos cube theta we need to calculate, which is nothing but 0.6. So how do I write this? Cos theta is nothing but what? It is nothing but adjacent by hypotenuse. So therefore 6 by square root of 6 square plus 8 square, or we know this, if I calculate this, then it will be 0.6. So this is nothing but 1.2 lux. Then illumination under either of the lamp, because if I calculate the illumination at point A, which is same as point B, because both are having the same candle power or the same intensity and same height as well. And midway is nothing but what? If the distance between them is 16 meter, then it will be obviously 8 meters. So thus we have calculated. And illumination under either of lamp is same as both. So therefore it is nothing but I by h square or actually the thing is that, sorry, at point B also and point A also will be getting the illumination from both the lamps, because the distance between them is little small, and we'll be getting the illumination from both the lamps. So therefore illumination at point B is nothing but what? Illumination by the lamp L1 and illumination by the lamp L2. So therefore this point B is normal to the lamp L2, and it is inclined at an angle theta to the lamp L1. So for L1 we have to use this formula, that is I by h square into cos cube theta. For L2 it is directly below, so therefore it is nothing but I by h square. So again, this is cos cube theta is nothing but adjacent is again 6, and cos cube theta is nothing but 7.09 meter. Sorry, hypotenuse is nothing but, and this is 100 by 6 square, which is nothing but 2.9 lakhs. So in this way we have to solve the problem. Okay. Thanks for watching the video.